So section 6.6 is what we're going to do today. Use proportionality theorems. Our objectives are to use triangle proportionality theorem to find the length of a segment, and use the triangle proportionality theorem to solve a real-world problem. The triangle proportionality theorem says if a line parallel to one side of a triangle intersects the other two sides, then divides the triangle proportionally. All right, so this, if we've got a triangle, we draw a line somewhere in the triangle parallel to the base, to the third side of the triangle. Then this section is, we can say that TR would be to QT as UR is to US. It divides it, it slices us up proportionally. All right? And then the converse is also true. If we've got a line and it divides the sides proportionally, then I know that it's going to be parallel to this one. Goes both ways. You'll see it. We'll do some examples just to see what I'm talking about. All right, so there's the rest of it. RT is to, so it compares across. You can compare next to or you can compare across. It does RT is to TQ as RU is to US. It doesn't compare across. It compares the sides, each side. So the top part of the side is to the bottom part of the side as this top part is to that. And then with our other, then if you have that situation, the sides are proportional, the sections of the sides are proportional, we can say the line is parallel. We'll apply this. Okay, so we've got this in the diagram. QS is parallel to TU, right? So what's the length of RQ? To solve this, we can say 4 is to 6 as RQ, which matches up with the 4, is to 9. 4 is to 6 as RQ is to 9. Cross multiply and solve. So we have 6RQ is equal to 36. So RQ is equal to 6. RQ is 6. Any questions? All right? In the shoe rack, they've got, let's label it. AB is 33. BC is 27. CD is 44. And DE is 25. Explain why the shelf is not parallel to the floor. So I would test that. I would make sure the ratios of the sides, they should be equal if the shelf is parallel. So we could take 27 is to 33, and we're going to test equal. So I put a question mark over the equal sign because we don't know it's true. We're testing to see if it's true. Question mark equals, and then we'd say 44 to 25. It's obvious those aren't proportional. One has a smaller number on top, the other has a smaller number on the bottom. But if you want to test it, you can cross multiply. But I can tell you, you can just look at it and say it's not equal, right? They're not equal. So you can draw a line through there. So it would be no. And you'd say the sides aren't proportional. All right? Any questions? All right. Excuse me. So it did the same thing, it just reduced the fractions. Transversals theorem. The transversals theorem says if three parallel lines intersect two transversal, they divide the transversals proportionally. This is the same thing as this triangle idea we had, right? Except I just have additional lines. So like if I took these lines, these lines that aren't parallel, right? If I extended them, they would make a triangle, wouldn't they? Right? And then you've got these this is your base, and this is parallel, and that's parallel. So it should split these up proportionally as well. Now you don't have to, when you do the problem, you don't need to draw this in the triangle. I'm just showing you it's the same idea as the triangle, except we're just working with parallel lines. So they're going to split the sides up proportionally. UW is to Vx as YW, WY is to XZ, and so on. UW is to WY as Vx is to XZ. Opposite sides theorem. The opposite sides theorem says if a ray bisects an angle in a triangle, so here's our ray, here's the angle in our triangle, then it divides the opposite side into segments. This is the opposite side. The segments or lengths are proportional to the lengths of the other two sides. It'll be more clear when we do the proportion. The proportion for this would be, so if this is the angle bisector, let's make sure we know that. Let's get this drawn. That's the angle bisector. It bisects this angle. If that's the case, then we can say AD is to DB. This side is to this side. AD is to DB, as AC is to CB. Right? So the top is to the top part is to the bottom part, as this top part is to this bottom part. Everybody clear? Okay, let's do some examples, then it's easier to see what we're talking about. So here in the diagram, angle 1, 2, and 3, they're all congruent. What does that tell us? If 1, 2, and 3 are all congruent, what does that tell us about these lines? Main Street, 2nd Street, South Main Street. What's that tell us? If these angles are congruent, this is a transversal. What would that tell us? Aaron? Yeah, all these streets are parallel. That's why they talk about that. All the streets are parallel. Okay? And then it gives us some lengths. GF is 120, DE is 150, CD is 300. We have to find HF. In order to find HF, what do I have to find first? Yeah. GH. Yeah, we've got to find GH. How would I do that? Using the theorem we just did on the previous slide. How would I set it up? Okay, I would take DC 300 is to 150 as HG is to 120. $300 to 150 as HG is to 120. Cross multiply and solve. So before I cross multiplied, I would reduce this fraction here. I'd make this 2 over 1. A lot easier to work with there. So that's 2 over 1. So we have HG equals 240. So if HG equals 240, then HF equals 240 plus 120, which is equal to 360. So it's 360 yards. Any questions? All right. They did it a little bit differently. You don't have to do it that way. You can do it the way I did it. They took the total length. They said 300 is to 450 is HG is to, yeah, I wouldn't do it that way. The way I did it is easier. All right. In the diagram, angle PQR is congruent to RPS. So that means we have an angle bisector. PR is an angle bisector. Given the lengths of the sides, find the length of RS. All right. How can I represent QR? There's no variable there. I have the total length of that side and I have RS as X. How could I represent QR? What would it be? Yeah.
15 minus X.
Right. QR would be 15 minus X. All right. Anybody remember from the theorem how I would set this up? What would my proportion look like? Okay, to do my proportion, I would do 15 minus X over X equals 7 over 13. 15 minus X over X equals 7 over 13. And then we would cross multiply and solve. So that would be 7X equals 13 times 15 minus X. So 7X equals 195 minus 13X. So that's going to be 20X equals 195. X equals, we'll divide 195 by 25, I think you'd get 97.5. 97.5 is X. And that's what we had to find. Any questions? Everybody get the idea? Everybody's got it. No questions. Okay. Oh, it's 9 point. I had the decimal in the wrong place. It's 9.75, not 97.5. I had the decimal in the wrong place. 9.75. All right, that's it for the notes.